Okay, so Miles said I could have one slide and make 1 point, but I thought, well, if I can fit 3 points on the slide, I'll do that. These are points that I think are critical issues as we think about the 1.5 degree issue and the special report in particular. So the first one, well, actually, to illustrate all of the points, I thought it'd be useful to show a typical type of scenario. So this red curve is showing a stylized curve of global average temperature over time. And it's showing the temperature rising above 1.5 to near 2 degrees and coming back down. So the first point I want to make is when we think about the peak in this warming level. So here we increasingly talk about carbon budgets. But I want to raise the point that carbon budgets remain highly uncertain. Some of those uncertainties we're starting to home in on, such as those around TCR and ECS. We're increasingly starting to think about non-CO2 forcing, but there are other uncertainties around Earth system feedbacks. And also the climate models we use are missing so many processes. We're only starting to put a nitrogen cycle into these. The second point is about this region where we're above 1.5 degrees for a period of time. Now this is something Martin Parry and I looked at a few years ago when we were thinking about 2 degree scenarios, but it's more relevant here. So I think we shouldn't just be focusing on what happens at 1.5, i.e. when we first reach it, or if we get there in the long term. We need to understand the temporary resilience in this overshoot period. Now that applies to thresholds, for instance around Greenland irreversibility, but it also applies to other more fast responding impacts and how we adapt to those. My final point is more of a technical one, but in terms of gaps in the literature, when we look at these overshoot scenarios, well, we're getting much better at constraining what happens as we increase forcing. There's still a lot of work to do in the period where forcing is declining. So there are major uncertainties that I think we need to address.
Okay, I'd like to ask Jan Fuglestvedt from Seneviratne.
Can you help me find the...
Isn't it there?
Yeah, very good. I would like to talk about some general points, and as we've seen, it's a very complex system that we're talking about, and a very complex challenge. So are we really able to communicate this knowledge to the broader audience? Are we using the right channels and the right formats? Should we use social media more actively? I think we have a huge challenge there. And also, to the policymakers, is the mutual understanding good enough? I don't think so, and I think we need to improve this interface between science and policy. And across the disciplines, that's really important to address the problem. The different disciplines, they have different concepts, different languages, different methods, and I really think we need to improve the interaction to solve the problem, so to speak. And if you look at the modeling, do we integrate this complex knowledge without losing what is essential for modeling the system? And can the climate models really give the impact and adaptation and sustainable development research what they need for their studies? And do we design the model studies in a way that inflates or limits the solution space? And will the mitigation studies give us false hope or exclude the opportunities when we look into the future? And what about all the implicit value-based choices in our studies? I think we should be more aware of them because they may have a strong impact on the results. And we need to communicate all the assumptions, etc., to the users. And do we have a well-understood pre-industrial and current state of the climate system? And this, together with the interpretations of the well below 2 degrees and the 1.5 limits, it will affect the mitigation and emission pathways and their characteristics. And finally, about uncertainty. Uncertainty will always be there. And I heard a colleague from Oxford saying, uncertainty is endemic but not crippling. And obviously, I think we need to develop flexible response strategies that can effectively absorb the new knowledge. Thank you.
Okay. Yeah, okay, we have a very short time, about 10 minutes for discussions with a very big kind of panel. So I'll ask for 2 or 3 questions and then we'll take them all at one time. Let's first go here and then down to Rachel to do it in one hit.
Very quick
And
question.
one more. Okay.
Richard Betts mentioned the small island countries, but only cursorily. But I haven't seen any data points, graphs about the impacts of these on the small islands, yet they're the ones who've been pushing this agenda item. So do we have a challenge for science here?
Okay, thank you. Now to Rachel and
Thanks very
Steve.
much. A couple of people raised the issue of comparing impacts of greenhouse gases with the impacts of mitigation technologies. And Sonia, you said that we should work towards integrated adaptation mitigation scenarios. And could you expand a bit on that and say, how do you think we should research that, and how much is that a priority, or is it just kind of too complicated to handle for the next special report?
okay, now I'll go to Steve, I thought, which is the guy in that guy, yeah, got him.
Thanks all for the presentations. A couple of points. Sonia, you showed that there's lots of uncertainty. You showed lots of work's been done, but then also lots of uncertainty. And I guess, how much do you think that will close by the time, in time for the special report? And Richard, you said that there's temperature rise locked into the system, even at the low emission scenarios. Could you give us a number on that?
Yeah, okay, good. Can we have those questions answered first? Someone grab a microphone and start speaking.
That on? Yeah, okay, so can you hear me? Okay, so yeah, the small island states, yes, that there is a challenge to science there. There is very little information specifically on that. There's not no information. There was a chapter on small islands in the last IPCC report, in the Working Group 2 report, but I think a lot more could be done, especially in terms of the commitment to long-term sea level rise. I mean, from the UK perspective, it's interesting that the UK has a lot of overseas dependencies, many of which are small islands, but in the UK's national climate change risk assessment keeps putting off dealing with those because there hasn't been the information. I think the research funders need to get on and fund some research on this rather than having to sort of cobble together some little bits of work from what we can find. So yes, there is a challenge to science there.
If I can add a word, there is literature emerging about methods to assess changes, for instance, in freshwater resources for small islands. There is still a need to better inform on sea level aspects, accounting for local processes affecting the response to sea level rise.
Yeah, so yes, answer 2 points. One is integrated adaptation mitigation scenario. I mean, I think this is really a key issue. I mean, your question was also how much time do we need for this? And certainly for the special report, it's going to be difficult, but at least it should be flagged, because sometimes it's kind of ignored in some way, because in the past, often the different working groups have been working partly in isolation. I mean, there was some interaction, some information flow, but maybe not sufficient. So it should be flagged, and I think there are some first attempts in this direction. For instance, there is already one model, IAM model, so integrated assessment model, that has been coupled to an ESM, and possibly there could be more efforts in this direction. It will take more time, but certainly maybe having first assessments showing what are the possible implications would be very useful. Regarding how much uncertainty, how can we reduce the present uncertainty? So as I said, for the temperature extremes, I think it's not totally impossible that we could reduce uncertainty, because there we could identify what is the source, so it's quite strongly related to some moisture feedbacks. I cannot guarantee it, but possibly we could find that some models are more realistic than others, so possibly we can reduce it. But I think even if we cannot, so for instance, if you look at hydrological change, P minus is quite uncertain, and there it's also in part related just to interannual variability. I think the important point there is maybe not to look at the total range, but looking at the lower part of the range. So basically, what is the type of change that you are willing to accept? For instance, between 1.5 and 2 degrees, the main change might not be about the median, it's about avoiding some possible impacts. So at 1.5 degree, you might be sure to really avoid certain impacts, while you cannot exclude some at 2 degrees.
Could we go on to answer some more questions? There's one here, somewhere else, one in the back, and someone has a third question for someone. Come on, get going, yeah, okay. Let's have one down here. Oh, sorry, sir.
Yeah. Policymakers, particularly from poorest countries and small islands in Paris, insisted on 1.5, and also the special report, assuming that scientific community will come up with some useful, mitigation, particularly adaptation strategies, and science would help them. But it looks like if you look at the ICMIP studies, as I think Richard showed, that the projections as of now, the science says it could be, if you take wheat or rice, +2 to -20. But this is the kind of yield projections we're making at 1.5 degree. Given that's true for all other crops as well. So given that it's really a challenge whether scientific community can deliver something really useful in the special report at 1.5 degree. That's of relevant. Given such high uncertainty when the world would touch 1.5, what are the regional diverse implications? Again, impacts such a wide range, 4 +4 to -20. This is the kind of projections on yields. So given that maybe scientific policymakers may be waiting for uncertain, some sort of a disappointment from scientific community.
Okay, and we have one in the back. In fact, we had one other in the back. We'd take the two of the back ones, but there's only one microphone. Sorry.
Yeah, I'm wondering what people think about the baseline dates used for defining pre-industrial. There was some variation amongst the speakers today. It seems like there is a convention to use 1860 to 1880 averages. But I'm wondering what you think about this, and in particular, what you think about suggestions that we should use an earlier date, which would add a couple of tenths of degrees potentially, and is obviously very important for communicating the message about how close we are to 1.5 degrees.
Yeah, okay, cheers. And we had one question just down in front of you.
Thanks a lot. Regarding small islands, most of the presentation today, not much on the oceans, and most of the small islands are on the oceans, and most of the warming has been taken down by the ocean up to now. What is the discussions on the 1.5 and the scoping exercise going to do with the oceans?
Okay, go on. Because we're hearing about small islands, we have one more question down the front. And we then go to the panel. Here. Sorry.
So I just wanted to come back on the point that Sonia made about trying to constrain on the basis of better understanding of soil moisture feedbacks, for example, the extreme temperature responses. Is there a challenge out there to the scientists that we maybe should be spending more time on assessing the processes in the models rather than just running more and more models, and that we could do a much better job at actually constraining some of these uncertainties if we actually focus more on those sorts of analyses?
Okay, good question. Yeah, okay, give it to Jason go first.
Well, I'll take the one from Richard, because that was the last one. But I think it overlaps the first question on uncertainty as well. Richard, I think you're quite right. Understanding the processes in the model is a useful way to go. It will help us in the longer term really start to constrain uncertainty. But that's not going to happen on the short time scale. So on the short time scale, and this relates to the first of the questions, uncertainty is something we will have to learn to live with. And actually, I think one thing that the 1.5 degree report can do is try to quantify that better so that we can think about how to apply risk-based management solutions around that, the uncertainty isn't going to go away.
I'll address Damon's point about the baseline. I think that is an important and also scientifically interesting one, but it's also something we shouldn't get bogged down in. I think it's important because, the Paris Agreement doesn't really define 1.5 or 2, so we're not really clear what we're aiming to avoid in terms of temperature targets. But we know what we're trying to avoid in a broader sense. We're trying to avoid dangerous climate change. So I think looking at what these warming levels mean in terms of dangerous climate change is a very useful exercise in trying to figure out what it is we're really trying to avoid. I don't think we should worry about are we trying to avoid 1.4, 1.5, 1.6 in terms of the actual nuances. So kind of yes or no is my answer.
Okay. Yeah, I'll just maybe answer to the point from Richard. Yes, definitely, that would be my answer. It's very important to look at processes as well. And I mean, obviously, there is only so much that can be done within a 1 year framework. But I would certainly support the suggestion to look more into that. And maybe not look only at statistics of climate projections, but also understanding what the divergence between models.
I would like to come back to 2 points, the baseline and the ocean. For the baseline, what's really important for publications is to clearly report what is the baseline that you use, so that when authors of the special report will assess the existing publications, they can scale them to a common reference period. Considering, for instance, the period where there are several temperature reconstructions, let's say 1880 to 1920, I think it's about 0.1 plus or minus 0.1 degree different from something that would be closer to a true pre-industrial, considering the 18th century, for instance. So differences are small. And this is particularly important also for studies performed using regional models, where the reference period can be the 1960-1990. Then it can be scaled to a common pre-industrial baseline. And then the ocean question and the small island questions are really relevant. But there will be a second special report of the IPCC on the ocean and the cryosphere and climate change. The scoping meeting will take place in December in Monaco, and therefore we need also to articulate what will be covered in the different products of the IPCC reports. There will also be one on land use related issues, and the outcomes of each scoping meeting will also help to articulate where there is room for a specific focus on some of the questions. And still on the ocean aspect, there's clearly a question on what are the ocean carbon cycle feedbacks when you decrease emissions. And this is something that was not fully addressed in the AR5 and was not consistent in the approaches developed in Working Group 3 and the emerging knowledge from the Working Group 1 scientific community.
Yes, okay, I think we have to go on to the rest of the day, but you have lots of time, hopefully in lunch break and coffee break, to continue these exciting discussions. So I'd like to thank our speakers and our panelists and your very good questions. Thank you very much.